Sequential search and string matching are examples for brute force. Sequential search I'm not going to discuss in detail because we have already discussed in the unit 1. This is the algorithm. For your reference I have put in the slide. Next one is brute force string matching. Here the problem is to find the substring in the text that matches the pattern. Input is two strings. One is text string containing n characters and another string is pattern which contains m characters. The overall idea of the algorithm is to align pattern at beginning of the text. And next is you are required to compare each character of the pattern to the corresponding character in the text until all characters are found to match or a mismatch is detected. If all characters are found to match, then it is successful search, return index, or otherwise you are required to realign the pattern one position to the right and repeat the step 2 while pattern is not found and the text is not yet exhausted. This is the overall idea of the brute force string matching algorithm. We'll see with the examples. The first example here is text with 21 characters, Ramachandra Pravina, and the pattern Rama with 4 characters. Here first step, as discussed in the previous slide, text is to be aligned with the pattern. So we have done this. Compare the first character of the pattern with the first character of the text. So it's matching. Here also it's matching. So totally we have done 4 comparisons. In general, if there are m characters in the pattern, then number of comparison in the best case is 4. So in the best case it belongs to theta of m. Next example is for average case. I don't want to discuss in detail. Just find out how many comparisons is being made in this for this example. Next one is example for worst case. The text containing 7 characters here and the pattern with 4 characters. This is the pattern and text is taken here. We'll see in the worst case how many comparisons is required in general. So align as usual. First character of the text is to be aligned with the first character of the pattern. So I have aligned that. Now start making the comparison. All 3 characters is being matched except the last one. So when I equal to 0, after doing 4 comparisons, fourth character is not matched. So again you have to realign the pattern 1 character towards right. So this is the next iteration, I equal to 1. Again in the 4th comparison there's a mismatch. So again I gets incremented. Now I equal to 2. When I equal to 2, again 4 comparisons. When I equal to 3, all the characters of the pattern is matched with the text. So with this what I can say is when I equal to 0, 4 and 1, 4 comparison. When I equal to 2, again 4, 3, 4 comparison. Totally 16 comparisons is being made. In general, if there are n characters in text and m characters in pattern, total number of comparisons made in the worst case is equivalent to n minus m plus 1 into m. It's equal to, in this example, 16. So with this example, it is easy to write the pseudocode for this algorithm. Look at what we have done here is I is varied from 0 to n minus m. N here is 7 and m is 4, total, that is equal to 3. So I should be varied from 0 to n minus m. That is what is being done here. And then every character of the pattern is to be matched with the text. For that, use the index j for pattern. Set j equal to 0 initially. So j equal to 0, and all the characters of the pattern is to be matched with the text character. So now the first character of the pattern is matched with the text character. In case if it matches, increment j, and this is to be done how long? Till j less than m, because number of characters contained in the pattern is m. So if this both condition is true, or if you are coming out of this loop with this condition j equal to m, that means all the characters of the pattern is matched with the text character. Now return I as the index where you found the pattern. This is successful search. Otherwise, again I gets incremented. This process will be continued. So when I equal to n minus m, in case if you don't find any such pattern, it will return -1. Now it's easy to understand this algorithm. So brute force string matching, here two inputs, one is text and the pattern. Text with n character, pattern with m characters. In order to find the pattern in the text, vary I from 0 to n minus m, j equal to 0 while j less than m, and pj equal to ti plus j. In case if this pattern character is equal to text character, then increment the j. So if all the characters of the pattern is matched with a text, then you will be coming out of the loop with this condition j equal to m. So return I is the index where you found the pattern. Again, in case if you are not coming out of the loop with j equal to m, then search will be continued. How long? Till n minus m. Once I value equal to n minus m plus 1, it will come out of the loop and it will return the value -1. We will see now analysis part of it. So I is to be varied from 0 to n minus m. Okay, so I is to be varied from 0 to n minus m, and j from, look at here, j from 0 to m minus 1. 0 to m minus 1. And in each iteration, the basic operation what you are performing is comparison. So one comparison. Simplify the inner loop. That is m minus 1 minus 0 plus 1 is m. And when you simplify this m into n minus m plus 1, this belongs to theta of n into m. So now we'll see strengths and weaknesses of brute force. Strength is it is widely applicable to almost all the problem, and it is simple to implement and yields reasonable algorithms for some important problems like matrix multiplication, sorting, searching, string matching, etc. Its weakness is it is not that efficient algorithm. Time taken to find the solution is more in this brute force. It's very slow and not as constructive as some other design techniques like divide and conquer, decrease and conquer, branch and bound, backtracking, greedy, and dynamic. So we'll see with the example why it is not that efficient. What made us to say brute force is not that efficient compared to other design technique with the example of exhaustive search approach in the next video. Thank you.